Chapter number 8 has to do with confidence intervals. And we touched on it in the previous chapter, in chapter 7, with regards to developing confidence intervals. They're very important in statistics and give you a range of possibilities so that you don't tie it into one specific number. So we're going to construct and interpret the confidence intervals, and we're also going to determine the sample size. A couple of years ago, I wrote a report for a board of directors in the United States, and I had to explain what a confidence interval was. I put a little section in the report at the beginning because most people are not stats experts or even have taken a course in statistics. So I simply wrote what a confidence interval was and how to interpret the results so that they would be able to understand the confidence intervals that I created. So we're going to have we're going to do confidence intervals we're going to do confidence intervals for samples, all right, and populations. Now, in industry, the real world, you use if you know the population standard deviation, you use Z. But as I've said many times in the recordings, very rarely do we know the population. We don't even know the size of the population. You know the size of the population, you can't calculate the standard deviation. So if the standard deviation is unknown, which is like the 99.9% of the time, you use t-scores, which is the sample. All right. And we're also going to calculate the sample size. How many people do I need to talk to before I get a certain level of confidence? So with confidence intervals, you have the point estimate, which is really the mean. And it's a single number. You have a lower limit and an upper limit. From the last chapter, I will make a statement. I believe the class average for this course will be 72%. That would be the point estimate. But I then say plus or minus 5%, which means the lower limit would be 67, which is 72 minus the 5, and the upper limit would be 5 more, which would be 72 plus 5, which is 77. And then I would say that I'm 95% sure or 99% sure that the average is going to be between those two numbers. So in this particular case, when you have a mean, we're going to use X bar, which is the mean of the sample. And when you have proportion, we're going to use the p-value, and z-scores. But the software will take care of that if we do it properly. So this gives us, as you can see, an interval estimate. And these interval estimates are called confidence intervals. The lowest you would ever have is a 90% confidence interval. So what a 90% confidence interval means, I'm 90% sure of my answer, which also means I'm 10% likely to be wrong. Just think about this. Would you want to walk into a meeting, an important meeting, and say, I'm 68% sure that this is a correct answer? People are going to look at you like, that means you're 32% chance you're wrong. So 90% is considered to be the lowest. The normal is 95 or above. When I did that report for the board of directors, I used 95%. So I could tell them I'm 95% sure that this is the correct answer. There's a 5% chance I'm wrong. And you know what? That's considered to be acceptable. Even in today's world, 95 is sort of the lowest, but never below 90. You never go in and say, I'm 80% sure this is the answer. So you can never be 100% confident, as you can see at the bottom of the slide. And normally we'll use between 95 and 99. And it's also very important to determine what are the consequences of making a mistake. What are the consequences of you being wrong? That's a big part as to how you set the confidence intervals. So here's an example. I'll let you look at this, and you've got the Z-score because they do know the population standard deviation, and it calculates it. And just as we did before, if you remember from the previous chapter's recordings, this is the same example, the 368. So we're 95% sure that with a sample of 25, that the population mean is between 362.12 is the lower limit to an upper limit of 373.88. So if you don't know the mean, you can estimate it from the confidence interval. And we have other intervals. That's at 95%. So we can say that we can change the interval to 99, 98, whatever again is relevant. You only take one sample. You don't take a sample of 25, then 21, then 37. You would use the largest, by the way. So the others would be redundant. So you've got your population, you take a random sample, and you're going to be, in this case, they're using, I'm 95% sure from the sample mean that the population mean is going to be between 40 and 60. So you have the point estimate, which is the mean in our case. You can use confidence intervals for non-means. You can use confidence interval for slope. You can use confidence intervals for a whole bunch of things that are not just mean. But for this, our purposes in this chapter, it's the mean plus or minus the critical value times the standard error. And the critical value is simply the t-score. And the standard error is the standard deviation. So again, you cannot be 100% sure. The statistics is all about how sure are you of the answer. And then of course the opposite, the tails, which will become very important in upcoming chapters, have to tell you what percentage of the time you're likely wrong. So this is just showing you a 95% confidence interval. The level of significance, the alpha, is the opposite. So you have a confidence interval of 5%. You have a level of significance. That's what the little funny looking A is. That's alpha, is the opposite. They always total to be 100%. So if you're 95% sure or confident, you are 5% unsure, which is the level, it's called level of significance. So this is a nice summary. For our purposes, the bottom left-hand corner, the one that's highlighted in the bottom left-hand corner, we're not going to use. We're going to use population mean unknown. Confidence intervals for proportion. So what you can look at, I'm not going to try and trick you on this, by the way, is if you're given the population mean, read it carefully, but I'll say I'm 99% sure or confident that you're going to use t-scores. For population proportion, you use z-scores. And I may also give you some websites on this. There are some websites that will calculate the upper and lower intervals. And so don't be surprised if I give you some websites that are not in the book, because Excel doesn't do confidence intervals. It only does it part way. So I'll likely give you some websites you can use on the tests, because that's how I would do it in industry. If you ask me right now, well, how did you actually do the calculations for those confidence intervals that you did for that report? I just went on the internet, typed in confidence interval, population mean, standard deviation unknown, or simply confidence interval, population sample means. And there's a website, and you plug in the data, sample size, the mean, standard deviation, those kind of things. What percentage, how confident you want to be, 95%, 97, 99, whatever. And the same thing for population proportion. So I'll give you those. And here's for the, again, if the standard deviation for the population is known, I've said repeatedly, this is really not that big a deal, but I wanted to include it because you're going to run across a lot of people who've taken stats, and some schools still teach it this way. I know that even though it's not necessary, that they haven't modernized their courses like we have, and they're still using the Z-scores and that, which is really out of date. Last time I taught the stats course, I didn't use Z basically at all. We just focused on T, which simplifies your life a whole lot more. Rather than having two to choose from, you have one. So again, you can see in this nice graph, we have the lower and the upper limits, 95%. And we're given the confidence levels. Again, you would never use the 80%, ever, ever, ever. Right? So you could just, whoever did this should just take that out. So 90, 95, 98, etc. And you're going to see you can see that the confidence level is the confidence coefficient, which is also called, just the level of confidence. And it gives you the Z values. So also, just as a, the alpha would be the opposite. So if it's 90% confidence level, it's a 10% alpha. If it's 99% confidence level, the alpha is 1%. Because sometimes you're going to be given the level of significance, which is going to be a number between 0 and 1. Well, actually, it won't be 0, but it'll be 0.0001 to 1, 0.1, sorry. Okay. So once again, I think your people are getting the gist of this. It's symmetric. It's plus and minus from the point estimate, which our case, the point estimate is the mean. So here's an example. You're given 11 circuits. You have a mean, you have a standard deviation, 95% confidence interval, and we're going to use software to calculate this. Rather than looking up the Z-scores and then plus and minus, the software will do that for us. So this formula is built in. You need to enter the X bar, you need to enter N, and you need to enter the standard deviation and the 95% or 99, whatever it might be. So we are 95% confident that the true mean is between 1.9932 and 2.4068. Now, unknown, this is the big area. The first 20-ish slides in this chapter are just building sort of a basis. This is the really important, the next two. Do you ever truly know the standard deviation of the population? And as you can see, there's a big exclamation mark. Probably not. In virtually all real-world business situation, the population standard deviation is not known. This is what I really emphasized last term. Because we're using the technology, it really does allow us to teach in the classroom the way you're going to do it in industry. So last term, I really emphasized the fact that we use samples. That's the reality. Or you use proportions. The confidence intervals I actually did for the board of directors that I mentioned a couple times, it was actually proportions, that confidence intervals that I did. And what percentage of the demographic was male, what percentage was female, and I did confidence intervals on that. And I was able to statistically prove that slightly more women attend, this was for a county fair in the United States, attend the fair than men. And why does that matter? Any of you in marketing know that. You're trying to find the demographics. We also did it on age, and we broke it down to time of day, and the percentages fluctuated throughout the day of what age group was there. For example, as it makes sense, county fair, it's kind of like the Calgary Stampede to a degree. And earlier in the day, while a lot of adults are working, or there's a younger demographic. And later in the day, there's an older demographic. And guess what? Consumption of alcohol will increase once the adults show up in the evening. So we're going to use S for the standard deviation of the sample. And we're going to use the T distribution that I've been talking about extensively. So we're finally to that point. And you can see the formula is identical with the fact that we take Z and we replace it with T, and we take the standard deviation of the population and replace it with the S symbol, which is the standard deviation of the sample. So, sorry, I might have said sample. The standard deviation of the population is replaced with the standard deviation of the sample. Sorry if I misspoke. The degrees of freedom is just an adjustment factor that you take the sample size and subtract 1. Against the software will do that for us. So, and this is again based on looking things up in tables. Well, we're not going to do that. We're either going to use Excel or we're going to use most likely the websites that I give you, and that will look up the values for you. So you don't have to bother with the tedium of having to do that. But the concept of confidence intervals remains the same, whether it be for population, for sample, or for later on proportion. That's the gist that you need to learn. Oh, it gives me a range of possibilities, and I can say I'm 90 whatever percent sure that the real mean is between these two numbers. Once again, this just shows you that as the sample size gets larger, the T distribution looks closer to the normal, central limit theorem, right? And you see the little note at the top. As T increases, it gets closer to Z. So here's some comparisons. You can see at 80%, you can see the T values is 1.372, and the Z score is 1.28. But when you have a sample size of 21, actually, because the degrees of freedom are 20, it becomes 1.325. 30 becomes 1.31. It used to be the cutoff point. You can see 1.31 and 1.28, not a big difference. So you can see very clearly numerically that the larger the sample, which means the larger the degrees of freedom, the T score becomes much closer to the Z score. Sometimes in the past they've used 50, which makes it even closer, but there was a practical reason for 30, and quite frankly the practical reason was you could only fit about 30 rows of information on one page. That was it. And we didn't have the ability to use it. I know it might seem simple to your generation, but it's taken a lot of years for this to become part of the norm. Same process as before. You find the T values, and Excel will calculate the T value, although we're going to use the websites. And you have the standard deviation, you have the sample size, and your same answer as before, except using T. So the sample of 100 with a sample mean of 110.27 and a standard deviation of 28.95, you want a 95% confidence. You are 95% sure that the true means the population. You can see the mu in the bottom here, that the population mean will be between 104.53 and 116.01. Once again, 2.5% of the time, which is half of the 5% that's not included, it'll be below 104.53, and 2.5% of the time, the population will be above 116.01. And if you prefer to just use it all in Excel and not the website I'm going to give you, this is how you do it. So you can have this pre-done where, you don't need the website. You can see they've done a very nice job of laying it out and showing you exactly how to enter the formulas. And what are you going to do? You're going to standard deviation, sample mean, sample size, and confidence. And then you could literally, if you set it up in Excel, you can do this. Part of the reason why we're showing you how to do it yourself, and part of the reason why we're showing you how to do it where it's sort of pre-done for you, is talking to my students who are working in industry. Some of them that even work for large corporations like Amazon. They tell me that Amazon is a very large company and they would have people within Amazon who would set this up for them. But even though Amazon can afford to have what are called data analysts who set this all up for you, so you simply plug in the top 4 pieces of information from row 4 to row 7 inclusive, there's still a lot of times when you have to do it yourself. So it's a combination. So there is great value for those of you who say, I want to know how to do it myself. I'm going to work for a small or medium company. They don't have the resources. They're going to expect you to be able to do that. So here, if you ever want to have to do confidence intervals, you can do it this way. I will also show you, like I said, I'm going to give you a website that will do this for you. So my students last term really liked the website. But we also want to show you how to do it basically on your own. So here it is, all nicely laid out for you. The formulas, they've done a really good job of showing you the data entry. They're showing you the descriptors in the column A, and then the numbers in column B, and they've shown you the formulas. So it's very well done. Should be, and if you want to prefer to use this for your tests, I will never know. I will only see the answers. I don't see the written work. Population proportion. So in this particular case, we want to find the proportion, which is the point estimate or interval estimate. So again, we've seen this before. It calculates the standard deviation. It's the probability of the event occurring, bracket 1 minus the probability of the event occurring, bracket all divided by the sample size, all taken by the square root. So and that's for the sample. The one at the top is for the population standard deviation, and then the one at the bottom is for the sample. But we use Z-scores. And again, I will give you a website on this, but we can also use Excel. So this is same concept. You take the P rather than which is the percentage of the time that the event occurs. And in this particular case, you can see plus or minus the values to the right. It's always symmetric. Confidence intervals, for our purposes, are always symmetrical. And the ones that I've ever seen are always symmetrical. So I'll say I'm 99% sure that all confidence intervals are symmetric. The concept is plus or minus the same amount. It's not like plus 3 minus 2. That would be asymmetric. So you've got 100%, 100 people, 25 are left-handed, 95% is confidence interval. You say that it's between basically 16.51 to 33.49 of people, the population that's left-handed. So you can see it just states it again, what I just said. Here it is in Excel. So if you want to use this, please be my guest. Once again, I will say, if you want to do this in industry, and sometimes people might not understand a website, you got to remember that you're going to deal with people who are not comfortable with statistics or was a long time ago. So if you want to do it in Excel, you can do it this way, and it really has to do with it's got all the formulas. I think it's incredibly well done. It's almost speaks for itself. All you need is the sample size, the number of successes, and the confidence interval. And when you set it up this way, you can change the variables. So this template, you don't need the website. If you really want to do it on your own as a learning experience, fine. And as I said, and I'll say one more time, it's times in industry where you're going to need to do it yourself, not necessarily for this, but you're going to need to. This is why we are including Excel as a core component of this course, because industry said they want that. It wasn't your stats instructor sitting around one day says, "Oh yeah, we start teaching Excel." Industry said, "You better start teaching students Excel. You're not doing a very good job at it," to be quite blunt. And not just at any one school, all of the schools heard the exact same message. I'm starting to teach Excel in my finance courses for a school that I teach finance at, and I don't mean to brag too much about this, but I was the first instructor at that school to include Excel in a finance course. Not because I was trying to show off, but because the CPA, the Chartered Professional Accountants, said you need to start teaching Excel. Or accountants use Excel all the time. Just even teach them basic things like this norm.s.inv inverse and things along that line. There's functions in finance that are for calculating payment, PMT, or calculating rate, etc., etc. Industry says they want this. And so determining the sample size for the mean or the proportion, we have to have an acceptable level of error. So how much error you're going to have. And again, that's very much based on what the consequences of being wrong. So if you're running a high-end hotel and you want to try to make sure that you're not going to run out of towels, I actually teach this in my supply chain courses. What are the consequences of running out of towels for the pool? Now, if you're running a 3-star hotel, people expect a lower level of service. Maybe the towel's not as nice, or you go down there and maybe there's no towel. But if you're running a very high-end 5 stars or higher-end hotel, people expect a much nicer towel, and some of those people will be very unpleasant if they go down to the pool and there's no towels. And you actually use that in something called safety stock in supply chain. So once again, determining the sample size. All right, for the mean. And here's the formula for determining how much should we, how many samples should we take? Remember, the lower the sample, the less confidence you are. The lower the sample size, the less confident you are in the answers. But the more samples you take, the more confident you are, but it becomes more expensive. And as you can see in this particular example, and a very important little point is you always round up. So 96.04, you round up to 97, which would mean in this particular case, you're more than 95% sure. But if you round down to 96, you're less than 95%. So 95% it's like 95% or more. So you need to sample 97. Sampling 98 will just increase your confidence. But you said I only want to be 95% sure, or I will accept 95%. And 95%, by the way, as you can see in the slides, is very common, and that is also very common in industry. This is a nice little spreadsheet again. And I'll show you these in the Excel examples. But a lot of these things that we're seeing when I talk about using Excel, there's these pre-done slides that you've seen in the presentations, and you also have them in the end of chapter. They've done one of the reasons I selected this particular book is it has Excel in it, and I think it does a really good job, I hope you agree with this, of demonstrating where to use it and doing stuff like this rather than saying, oh yeah, figure it out on your own. And a little note at the bottom, make sure you include the roundup. So the number is 96.0365. You can't sample a decimal. You can't have a partial sample, but so you round it up. And then we're going to do the same thing, except for proportions. That was for means, if I didn't make that clear. Now for proportions, same kind of thing. It's becoming fairly repetitive. You want within plus or minus 7%, within 95% confidence, and the sample is 0.15. And by the way, if you're not given the proportion from the sample, or if you don't know it from the population. So for an example, if I said, I'm trying to estimate the percentage of Norwegians who like chocolate ice cream. I have no clue what percentage of Norwegians like chocolate ice cream. You use 50%. So if you don't know the proportion, then you use 50% as your p-value. So keep that in mind. If you're given a problem that says, do a confidence interval, and it says, well, I don't have a proportion, you use 50%. That's the default. So in this particular case, and you see that they use Z because it's a proportion, and means are T values, proportions are Z values. And so you can see it's 99.96. You would probably normally round that up to 100. But even if it was 99.06, you would round up to 100. And once again, we have our nice little spreadsheet all pre-done for us. You can have this sitting beside you when you're doing the test. And if I'm a student, I already have this done. I'm creating my more than just a cheat sheet. Okay, I'm putting these in Excel because I know I'm going to get these questions, and all I have to do is make sure I pick sample size, proportion. I've already got it done. I've tested it out to make sure that it works, and I simply have to plug in three numbers. The 0.15 as the estimate, the sample errors, this is the plus or minus 7%. Confidence, everything else is done for me. I don't even really care about the middle part because I've already got that pre-done, and it's showing me nice and clearly what the formulas are. I don't have to guess. And then I got the final answer. That's what I want, so I earn my marks. That's what I'm going to do. I do not want to be doing this during the test. The test will be long enough that I will expect you to have this pre-done. All right. So if you think you're going to have, I'm going to start creating these formulas, that's not the point of the test. The point is that the test is, do you know if I find a confidence interval for a mean or if I find a confidence interval for a proportion? That's the point of the test. That's the hardest thing to determine. When I did that report that I mentioned a couple of times, the first thing I had to do is sit down and say, okay, I know it's a confidence interval I want to do, but is it for mean? No, it's not for mean. It's for proportion. Okay, and then away I went. All right. You can read this about ethical issues, the sample size. This is part of where you can skew statistics. You can take a very small sample size of say like 11 people, and then expand that to the population of Canada. That would just be ridiculous. You have valid statistical numbers in the sense of your calculations would be right, but the conclusions would be totally unreliable. And so we've done confidence intervals for mean and proportion, and we calculated sample size.